Okay. Well, today we have Rachel Rudolph. She is our extension vegetable specialist. We're so glad to have Rachel here today. And she's going to be talking about rain-fed drip irrigation. I think she's been using it in her high tunnels, but it's an application that you can adapt to your vegetable gardens, your raised beds, different applications like that. I am thinking, is that correct, Rachel?
Yes. And so, this example in the video is a commercial, small scale commercial example, but it is adaptable for various sizes. And what the plan for today is, if people are wondering, well, why are we playing a video? This video, Dr. Brent Rowell, you can see him in the video next to me. He's retired now from UK, but he did an extensive work in developing countries with rain-fed irrigation, low pressure, ultra low pressure systems. And so it is possible. There's just a lot of things to keep in mind. And so this video is going to walk through details, and then I'll give a little bit more information after the fact. And we should have plenty of time for questions afterwards.
Vegetable Specialist at the University of Kentucky. This is Brent Rowell, International and Sustainable Ag Specialist at the University of Kentucky. And today we're going to talk about rainwater catchment. So we are at a small commercial farm outside of Lexington, Kentucky. They've been using the rainwater catchment system that we're going to be showing you today for about 5 years, there roughly. And just to keep in mind, this is November. So they're kind of in a transition period. So that's why you won't see too many things growing. They're kind of taking things out and putting things back in. So that's why you're wondering why there's a lot of weeds and things not actively growing. That's why. But the system is still totally operational. And we'll walk you through the ins and outs, things to keep in mind, and some add-ons for a potential rainwater system for your high tunnel. So the first thing, Brent, you're the aficionado of rainwater catchment systems here at UK. So the first thing people need to keep in mind is tank, right? You need a tank first.
These are sort of international standard for transporting liquids in container ships and within the country. It's called big tanks. 1,000 liters, 1 cubic meter, about 275 gallons. And you can find these everywhere. Secondhand, they run about anywhere from $40 to $100, depending on the condition. Definitely want to look for the one that's had food products or soft drink products or something like that, and it's food grade tanks. But they're very sturdy and readily available, so they hold nearly 300 gallons.
I think NRCS, they provide an example of a tank that's slightly bigger than big, black tanks. So, you're not absolutely down to buy something like this, but this is a, upcycled product that is fairly readily available.
Yeah. The only difference with the really big tanks is if you need to elevate them,
right,
get off the ground. These ones here are not elevated other than a few inches, but we have others that are up 2, 3, 5 feet off the ground.
Yeah, let's talk about that. So that's kind of we see water tanks in cities and towns, right? And they're really high off the ground. And so people have translated that kind of idea to these kind of systems, but it's not absolutely necessary, right? For these tanks to be super high off the ground.
No, and it depends on the size, the plot, or how come you can't really get with a larger space, you need more pressure. And the height of the water column translates to the pressure. And this, for example, I marked it here a few minutes ago. Right here, if the water is at this height, it's 2 feet 4 inches. That's equivalent to 1 pound per square inch of pressure. It doesn't matter how big this tank is, it could be 500 gallons. It only matters the height of the water between the water level here and the ground that you're irrigating. So we found in hundreds of tests here, UK, and also in Southeast Asia that we could irrigate even up to a quarter of an acre with about 5 feet of water pressure. Sometimes even down as low as 3 and 4 feet. So
And
you
your
know, 1 to 2.
standard-
Yes.
Yeah, and your standard tunnel is point,
Yeah.
let's say a 30 by 96 tunnel is 0.06 of an acre. So we're well within range to be able to irrigate with something like this at the height. that you need.
And this tunnel is only, I don't know what, 12 by 60 or something.
Yeah, maybe 15 by 40 or something like
But
that.
they've been irrigating with this tank for several years now. You might think, well, the drip line's close to the tank, going to put out a lot more water than those are the things. So
Why does
this size tunnel, that's not the case. It's extremely uniform if you follow a few simple guidelines.
And those guidelines are,
Well, the first thing is that you need a fairly large opening from the tank. And you need to carry on that opening size all the way to where you take off the drip lines off of the lake. And in this case, it's 1.5 inch PVC.
So this, contrary to popular belief, you know, when you think of a water hose, that's pretty small, that's 3/4 of an inch. And you say, oh, well, that has great pressure, right? Well, that is pressure coming from, you know, municipal water in the system, right? And so actually we want this opening and the following main line, let's call it, to be as big as possible. So 2 inches, 1.5 inches, you want it to be actually very wide for less friction. And that is really well explained in the publication that I think Sharon shared with everybody. So I really encourage you to look at those 2 publications that kind of are complementary to the video. So what happened was Brent Rowell created those publications a few years back, but we kept getting a lot of questions from people. And so we kind of made this video to complement those publications because everyone's a different type of learner, right? And so you may be better at reading this and comprehending it that way. And sometimes visual helps people. So, so this is a high tunnel. And so you can, they do drip irrigate with that tank. And so that's something to keep in mind. As he's pointing out, right, there's the water column, 2.31 equals 1 PSI. They buried their line because of mowing, but you don't necessarily have to. So this goes underground, but you wouldn't necessarily have to do that. And if mowing or weed eating is not a big deal to you. It did freeze and break. So this is all PVC pipe. So it's very sensitive, right, to freezing. And so really all that would require to keep things intact is to drain this system in the winter, right, before the first freeze, drain it completely, and then you won't have that problem. A couple other things to keep in mind. So here is kind of I think he used one of those really long dusters that you can get at Home Depot for ceiling fans. And you can see there's some growth on this tank, and that happens because it's clear and the sun passes through, right? So you get some algae growth. You can see it on this one too. And this, if you get one of these clear tanks, you can either paint it, that's an option, or you can use one of these brushes to clean it out. And that's an option too. And you just kind of scrub the inside. So then a couple other things to keep in mind. Oh, and NRCS has a black, usually provides people with a black a tank. So there is that. And you can see the gutter connection here. I will say a couple more things about that before I switch to the PowerPoint. The gutter connection here is really important. And so if you are going to do rainwater catchment, it does need to be attached to some sort of roof in some way, whether it's a shed or a barn or your house, right? Your garage, maybe, depending on where you are. And so we recommend putting up a guard on your gutters. It's the same kind of thing that you would use for your home to protect against leaves and debris getting in there. As you could imagine, that could easily clog things up and just create a lot of headache for people, unnecessary headache. There's also a little screen that goes in here. It is literally part of like a window screen that you can put down in there and will also collect extra debris. You can mount these. You do not need to be a complete expert to mount these gutters, but you should keep in mind that they do need to tilt moderately towards your tank, right? So they do need to have a slight angle to them. And they also, the parts, the components, right, need to be very well made. So I would either hire someone that does gutter installation or go to a store that actually sells professional grade gutter parts. So the mounting pieces that hold the gutter onto whatever structure you're mounting them onto, those need to be really well made. The ones at Lowe's, just like off the shelf, and Brent talks about this in the video, they gave way after, a bad storm, basically. So they're not recommended. So keep that in mind. So with that, I am going to kind of talk a little bit about some things to keep in mind. I do want to share, let's see, I do want to share a few things for people who are interested in, maybe the nicer, maybe the prettier option, I guess, of rainwater catchment. So you are probably looking at, so this is at my house, and obviously this would not completely satisfy a garden, but it does help water my front yard plants. I use this all the time in the summer. The next thing is, let's see here. It is connected to this thing, which we cut into the gutter. And so you could do this on a much larger scale, right? We just didn't need this, but if you had a larger tank, you could connect this to your gutter system at your house and basically feed this into the tank. And so there is a little, component on my particular tank that keeps bugs from getting in, and like a little screen. And so this has worked really well. And so this is really small scale, but it could, all the water coming off of our roof, or probably half the water coming off our roof, can come down through this spout. And so once the tank is full, it then goes back out the normal part of the gutter. And so this has worked really well for us. And I think on if you had a larger tank, it could really work for a garden, a vegetable garden. So let's see here. So I'm going to talk about, so first of all, I'm talking from a commercial standpoint, but a lot of this should be very applicable to homeowners or small scale growers, garden master gardeners, and that type of thing. So for vegetable production, we 100% recommend drip irrigation. And a lot of people are hesitant to adapt or adopt this practice because it looks really complicated, right? And so the components of, we're going to talk about the components briefly and the pressure that you need. And I think there's also a misconception about how much pressure you need. And if you have a garden and you have low pressure, then, you know, zones are really important. And we'll talk briefly about water needs of crops. And so this is kind of what people picture when they think of drip irrigation, right? And this is super intimidating and not necessary. And to properly irrigate your garden, you do not need a system like this. I don't have a system like this. I don't know if I've seen anything even remotely close to this in Kentucky. So, you know, that's the kind of thing that I think really throws people off and scares people. This would be a much more straightforward design, right? And so when we're talking about the main line, this is the line coming directly off of the, if you've got a tank, right? Or your spigot at home, whatever you're deciding. We're talking about rainwater today. So I'll keep it in the realm of tanks, directly off your tank, right? So this is the main line or the main pipe, and then the laterals, which is what is actually providing the water source to your crop. So pressure, right? So in order to make drip or to make rainwater work, you do need to move the water from the tank to your vegetables, right? To your garden. And so either that's going to happen with pumps or that's going to happen with gravity. You will need most likely some sort of filter, and I kind of talked about that, a screen or something. If you're using, for the purposes of, you know, if you're using a lake or a pond, you definitely need a filter, and that would be considered surface water. You need the drip tubing to the crop. That's the laterals or the drip tape. They sell similar kind of pieces, smaller scale pieces at Lowe's. You need some connectors. We'll talk about that. Maybe maybe at some point you scale up and you get into the fertilizer injections and that kind of thing. Backflow prevention for rainwater catchment, you would not need that. That is if you're connected to municipal water. So you've got the main line coming down, right, from your tank. And I'm guessing for most people, you will not need a submain. This would be if you were really larger scale, you'd have a main line and then then something else coming off that, and then you would have your laterals. But modern drip tape is getting more affordable. Currently, you know, plastic components are a little higher now than they were because of the shipping and the transportation issues, but it is pretty affordable. The really interesting thing about drip tape is that if you open it up, if you cut up a piece, it has kind of a zipper looking look to it, and it basically keeps things from getting in. Things can only get out, right? And the slits that allow the water are very small, but still allow water to pass through. And so it's pretty fascinating. And so you'll need connectors from, you know, your laterals to your main, mostly probably in the case of gardeners, just to your main line, but maybe your submain. You would need a punch, something to connect, right? And you can use, here is an example of lay flat, but a lot of it is orchard tubing. That's also very possible. In the case of what I have at home, right, I have basically kind of a spigot connection to my tank. And so you could, you know, if you're not irrigating too much, you could connect something directly to that and just away you go. But again, the pressure is really important to keep in mind. So here's a really nice photo of what was in the video, right? So you can see there is a slight angle to this gutter. That's really important to keep in mind. That the water still needs a little help going downhill. And so it's all the water coming off of this high tunnel. And this high tunnel is not very big. It's probably 15 by 44 feet. But you know, in a good rainstorm, I'm imagining that this tank could easily get filled. So low water pressure is considered 8 to 15 pounds per square inch. If you have a large system, you're going to need more pressure than that. Again, a PSI is pounds per square inch. 1 PSI is 2.31 feet of head. You will not need a pressure reducer for rainwater. So here is a great setup. You can have 2 tanks and one kind of, they both feed into the same main line, right? They're connected, and then they both kind of drain equally. And they've got them propped up, so they're getting a little bit more pressure, a little bit more, probably several more PSI than they would if they were on the ground. They're probably at least 2 feet off the ground. So if you imagine these are filled, you would have several feet of head for, you know, and plenty of water pressure for a garden. You can have pumps. We won't go into that today. This is larger scale, but pipe size and water flow. So it is kind of counterintuitive, right? It was for me anyway. So the larger your pipe, the more flow, right? So really skinny water hoses are not gonna be ideal if you want to extend, if you want to be able to water, you know, 50 feet of row length, right? And so again, here's another example, a tank. Here's the main line. Here would be a submain, and then your laterals, right? And so imagine this tank is has a gutter onto your garage, right? Connected to a gutter on your garage or on your barn or even like a shed, right? And you could build a little platform. It would not need to be terribly tall. And if you had a valve here and a valve here, you could irrigate one zone, right? Turn this valve off, irrigate this zone, right? And so this is totally doable. Brent Rowell has tested this multiple times, and it is achievable. And so the key to it is, if you've got a large garden, is to just break it up into zones, right? And so you can have a valve that can close this off, open this up, right? Close this off. So break it up into zones. So you don't have to cut down on your garden. You just have to design your irrigation in a way that your rainwater, your tank can get it all. So determining the zone size is basically you can time how long it takes to fill a known volume. So a 5-gallon bucket, for example, or a 50-gallon drum. And then you divide the volume by the amount of time it took to fill that volume, right? So if it took 1 minute to fill a 5-gallon bucket, that's 5 gallons a minute, right? And that's your gallons per minute. It took 10 seconds to fill a 5-gallon bucket. You will still need to convert that into gallons per minute, right? And so that's just doing the conversion from seconds to minutes. Drip tape always has this information on there. I imagine the stuff that you can get at Lowe's will also have some sort of, it will also need a certain amount of flow to operate, right? A certain number of PSI. That information should be on there, and you just need to look for it. And so keep that in mind, right? So that gives you some guidance. So 0.5 gallons per minute per 100 feet. So really, right, if you have 1 gallon per minute per 100 feet, you should, you should be fine. So if you know your flow rate, what size zone can you irrigate? So flow rate is 30 gallons per minute. Let's say this is going to be way higher than a rainwater catchment system, but bear with me. So you would just divide that GPM flow by the drip tape's flow rate, which you should be able to have, and you can get your zone. So this is 6,000 feet. In this example, 6,000 feet is the total length of this drip tape that you can irrigate in a zone. So it can be 10 times 600 feet, right? Or 20 times 300 feet. And so this is still applicable to a smaller garden, right? So it's 6,000 total linear feet. And so you can break that up into smaller, shorter pieces, right? So in the case of a garden, right, with 30 gallons per minute, you could easily do, 50 rows of, much shorter rows. So if pressure is purely from a tank, it will most likely be ultra low pressure, and it is very possible. And here's this black tank that I was talking about earlier. This is usually, I see this usually from with high tunnels that were part of the EQIP NRCS program. The only thing is that you may not have enough water to irrigate on rainwater alone. So for a small garden, right, that may be possible, but you still may end up, with a little bit of stressed plants occasionally. Just it really, as we know, right, the weather is fairly unpredictable, and we could just get a total deluge, or we could be, no water for 2 weeks, that kind of thing. And so maybe you want more than one tank to have some storage. If you are absolutely 100%, I'm only doing rainwater irrigation, then you're going to definitely need more than one tank to hedge your bets on things. You can also use a small pump to the tank, or from one tank to the next. And that is discussed in the video of a solar pump option. And it's pretty small and it's pretty affordable. And so if you're kind of going off the grid, or you're interested in solar power, that is discussed in the video, and it's very accessible. Okay, so a question for the crowd: which has more pressure? So this is a 10-gallon tank. This is a 50-gallon tank. They're the same height. I'm going to check the comments, or somebody can blurt out if they want. Which has more pressure? Same. Okay, I suspect some of these people have already heard me talk, but yes. So this is 2.3 feet, 1 PSI, and oops, they are the same. Volume does not matter. It is the height of the water column, okay? So if this 10-gallon tank had water, way up here, then we would be, having a different response. And so keeping in mind, right, if your tank is up high or you have a pond, right, it's still, we're measuring this overall. Uphill loss, downhill gain, overall 60 feet, right? So there is this, but hopefully this hill is large enough to compensate and get it over this little hump and then back down to your field. So 60 feet, 26 PSI. So 6 feet, 2.6 PSI, 3 feet, 1.3 PSI. Here's some more examples. So, and this grower, I have discussed this with him, right? He says, these are on the ground. You can see how low they are. part of that is because of the wall, where the walls of his high tunnels start, right? So these are side walls, what we call side walls for high tunnels. And he has the gutter right above this. And so he couldn't really place it there's, up here maybe, but that would probably be difficult and you'd probably rip the plastic. And so his tank is very low to the ground. So it's a really large tank, very, very low to the ground. And so he has struggled to effectively use these really, nice tanks for his high tunnels. He uses them, but they basically need to be full all the time to get them to work. So with ultra low pressure, the irrigation zone will be much smaller, as I said, but the calculations are the same. And so for example, crop water use, right? And I was talking about, you might potentially run into some stressed plants if you're only relying on rainwater and maybe you only have one tank. So here's an example of a tomato crop water use, thousands of gallons per day or per acre per day, right? So this would be, I translate this to 500 gallons, right? In the first week after a tomato crop, 500 gallons per acre per day. Well, that translates to about 11.5 gallons per 1,000 square feet. So that's the size of a hardy garden, I would say. Certainly people have larger gardens than that. So that's 11.5 gallons per day for 1,000 square feet. So really it's, if you were curious, and maybe a lot of the information out on the internet is in per acre basis, right? You would just basically divide your gallons per acre by 443,560, which is the square footage in an acre, and you'd get the gallons per square foot. And then I went ahead and multiplied it by 1,000 because I thought 1,000 might be a good size for a garden. You could do 100, you could do, 500, whatever you wanted, to find out that you could multiply it by whatever your space, your garden, to kind of get an idea of what you need for your crop, right? And so tomato crop use. And so they're making some assumptions here that the tomatoes are probably 18-inch spacing apart and probably 5 foot between beds and stuff like that. So you would need to make a few assumptions, but you would have a pretty good idea of what your target would be. And I would imagine peppers would have probably a fairly similar crop water use. I think I might have taken that slide out. A lot of the fruiting vegetables are going to have, the solanaceous crops are probably going to have very similar water usage. And that information is out there, and just check your source. So water use changes with growth stage. That's probably not too surprising for people, right? Obviously, a little transplant needs less water than a flowering, fruiting plant. And so keep that in mind. And so that kind of correlates with this, right? First flower, first fruit, and harvest, right? You need more water as time goes on. You can track or measure your soil moisture. That helps. You can also use a water meter. You can find those on Amazon. I have several that I think work really well and they're not terribly expensive. I can share that with people. But keep in mind, if you're attaching, that water meter is probably going to add some, lower your pressure even more. So take that with a little. Be aware of that if you're curious about how much water you're using. There are some other options to monitor soil moisture. This is a little bit more high tech, but it's very visually appealing, in my opinion. It's basically kind of a stoplight kind of situation, and you can just give a quick look and wet, dry. So if the dots as the dots disappear, you are drier, your soil is drier, right? And then when to irrigate. So right, for vegetable production, we do recommend drip irrigation because overhead irrigation can really lead to a lot of pest and disease issues. It's also just not very efficient. And so I'm assuming if you're interested in rainwater catchment, you kind of have that already, that idea in your head that, you know, you're gonna apply water as needed, and you're gonna carefully dose it out. So growers will need to know their flow rate in order to know how large of an area that, that can be irrigated at one time. And regardless of whether you're using a pump or gravity, the calculations are the same. The amount of water applied is dependent on many factors. I get that question a lot. How much water do I need to apply? Right. And so the crop growth stage is important. The soil texture, the temperature, the humidity outside, all that plays into it. What I've given you is kind of a generalization of how much water. And then you can apply irrigation based on soil moisture. So if you put a valve on your tank, right, you can turn it off, you can store that water, and then you can monitor the soil moisture and only irrigate as needed, right, instead of every day, right, at 8 o'clock or something like that in the summer. So these were the two publications that Sharon sent out: simple calculations for small drip irrigation systems, and then off the grid low pressure drip irrigation and rainwater catchment. This is for small plots and high tunnels. I think gardens definitely fit into that category. And then the Center for Crop Diversification has quite a few other irrigation resources that I think would be helpful for people the more as you get more interested or more curious about things.